Thank you, everybody. Can you hear me okay? All right, great. So before we get started, I understand PCI is a pretty boring topic, so I'll try to keep it a little better than what most people usually associate with PCI, which is, acid reflux and all that other fun stuff. So PCI is a big topic, and most likely I'm not going to be able to talk about everything in this talk. So I tried to keep it related to what developers really need. And so if you have any other questions that I don't cover, feel free to come see me after, or we can follow up with, I've got another blog post that I can post that's going to give you more information. But the whole point is just to give you enough information to get you started so that you can go down your path to PCI when it is. So first off, my company, .cloud, paid for me to come out here. So I'd just like to thank them. Also, they're hiring. So if you guys are interested, just come talk to us. If you don't know what .cloud is, basically it's a place to deploy your Django apps. So check it out if you want to do that. My background, I currently work at .cloud as a site reliability engineer. Before that, I worked at a company called CashStar. I am not a certified PCI expert, so whatever I tell you, it won't hold up in court. Like, you go get someone that's certified, and they can actually get audited and also subpoenaed. So go talk to them. So basically, I learned all my PCI stuff when I was working at CashStar. CashStar is an electronic gift card platform built on top of Django. They've got hundreds of merchants, a lot of big ones, and they've got many millions of dollars of credit card transactions every year. And when I was there, I pretty much started the engineering team, and it was very interesting because I didn't know much about PCI until all of a sudden someone asked me, are you PCI compliant? And as I was researching to find out what PCI compliance was, I realized there wasn't much information out there. So this talk is pretty much a summation of all of the stuff I learned while trying to figure out how to get CashStar to be PCI compliant. So hopefully your path to PCI compliance will be faster than mine. All right, so I'm going to do a quick survey. Show of hands. Raise your hands if you own a credit card. It's pretty much everybody. Have you heard of PCI before? Pretty much everyone. Do you know what it is? All right, that's still pretty good. That's like half of you. Now, how many of you have a website that accepts credit cards online? That's pretty good. That's not bad. Now, do you know, the people that had their hands up, do you know if you're PCI compliant? Oh, okay, so it wasn't everybody, so that's hopefully after today you'll know a little more than you are. So before we get started, we're going to go in a little more, figure out where we are. So the United States is a credit card nation. There's 1.4 billion cards in circulation. That's roughly 7.7 cards per person. That's ridiculous if you ask me, but that's the way it is. 181 million adults have credit cards. There's also 20 billion credit card transactions every year, which is roughly 12.9% of our GDP. If you look at the percentage of transactions, Visa is the leader, followed by MasterCard and American Express, and then there's a bunch of other people, Discover and so forth. Now, every year, I don't have that chart here, but every year the numbers are going higher and higher. And as the credit card numbers are going higher and higher, fraud is increasing. So 10% of Americans are victims of credit card fraud every year. About $400 on average is the typical credit card fraud. There's $5.5 billion worth of worldwide credit card fraud every year. Has anyone been a victim of credit card fraud? Yeah. So that's a good chunk of you guys here. So it doesn't have to be a lot, but it's just the fact that someone had your credit card number shows you how easy it is. And how are people getting your credit card information? Before the internet, they were dumpster diving. So that's why they always recommend shred your documents. They'll steal your mail. They'll actually steal your wallet by robbing you on the street, breaking into your house, stuff like that. Now so before the internet, it was very personal. They had to actually go to you to get your information. Now with the internet, they're lazy. They can just sit at home, they can create a little script, and they can start phishing you, they can hack you, they can do all these fun things. What's interesting is as the internet has gotten more popular, hackers have been getting a little smarter. Instead of going after one person at a time, they're saying, hey, why should I go after one person and get only data about one person or one household? So they started going after bigger companies. Like, why should I go after one person when I can go after a company and get millions of data? So these are the companies that have been hacked since 2005. There's roughly 12 of them. I'm pretty sure you're familiar with a lot of them. TJ Maxx, Bank of America, so forth. So this trend of people getting hacked, companies getting hacked, has been going up year over year for a little while. Credit card companies weren't sure what to do, so they started creating their own individual programs to figure out how can we combat this problem. Then in 2004, they basically smartened up and they all decided to work together. So instead of having 5 or 6 different programs, they decided to have one big program. The big players that joined are Visa, American Express, Discover, and JCB. And in June 30th, 2005, PCI 1.0 took effect. What is it? Why was it created? Basically, there was no common standard for internet transactions. Everyone was doing their own thing, and because of that, there was all these holes. So they basically wanted to give the merchants a guide to create their payment system so that if they follow this guide, they'll have best practices for everything. And it's, for you personally, the first time I heard PCI, I didn't know what it was. Basically, I thought it was a PCI port for a computer. Basically, I'm looking it up. I'm like, what does this have to do with payments? And like, do you put a credit card in there? Do you swipe it? Like, what's going on? No, it's not that type of PCI. It's basically stands for Payment Card Industry. DSS is data. I get it written down here and I can't find it, but basically it's just the standard that the payment card industry came up with. It's roughly 12 core components with 250 controls, which just basically means there's 12 high-level steps, and underneath those, there's a whole bunch of sub-steps. There's 4 certification levels. The current version right now is 2.0, and it's not a law. So if you don't follow PCI compliance, you're not going to get arrested. So it's not anything like that. It's more just it's a set of protocols that you have to follow when you agree to accept credit cards. So I'm going to go through the different things very quickly here, high level, just to show you that there's nothing scary. There's nothing that's going to be too crazy. The first one, install and maintain a firewall. Most people hopefully do that today. If not, you should probably be doing it. Change your default passwords. It's amazing how many people don't do that. Protect stored data. It's as easy as putting a password on it, making sure that if it's a server, it's locked down, and there's many different things that go along with that. Encrypt transmission. Use SSL, use SSH, VPN. Use antivirus software. Develop and maintain a secure system and applications. Restrict access to the data by the business need to know. So basically, your DBAs, your support staff, your programmers, they probably need to know. Interns, CEOs, probably not. Keep the data with the people that really need to know. And so it's basically, if the data is in the smaller subset of hands, you don't have to risk losing the data when someone, like a CEO, happens to go on an airplane and leaves the laptop and completely forgets about it. Number 8, assign a unique ID to each person. It's very common for people to use root or developer or some generic QA password and username. Give everyone their own username and password so that when you're looking through the logs after something happens, you know who did what and when. You're not just saying, oh, developer logged in 100 times. It could be from any one of these people on this team. Restrict physical access to cardholder data. So you could have the latest OS patches, you could have all the greatest software written, but if your server is just sitting there in your closet at your office, and your office is wide open, someone can walk right in, steal that server, and they could easily just pull the hard drive out and you wouldn't even know. So make sure it's not just your software, your physical hardware is also protected. Track and monitor all access to network resources and cardholder data. That's data. Regularly test security systems and processes and maintain a policy. So those 12 were pretty basic. There's not much to them. There's sub-questions for each one of those. I won't go into all of those, mainly because there's a lot and they're pretty boring, and you can read the doc if you really want to. I'm going to go into the ones that most likely you guys are going to, that's going to affect you. So most people don't really know how PCI certification works. The way it works is you fill out a SAQ, which is a self-assessment questionnaire, and you have to do this yearly. When you're filling this out, you also figure out what level you are. And as you're doing this, you make sure that you follow all the guidelines for those levels in that SAQ. You fix any issues that happen, and then for most people, you just sign it saying, yes, I agree. And that's it. It's a self-assessment. You don't have to have anyone else come in, and it's really easy. The one thing that's important is when you're signing it, it's kind of like a legal document saying you agree that this is what's going on, and if you lie, I'm not sure what they can do, but it's basically, it's not like it's under oath or anything like in court, but it's like a legal document. So a self-assessment questionnaire is a questionnaire with lots of questions about your payment system. There are 4 levels. Levels are based on certain criteria. Everyone is required to fill one out for PCI compliance every year. This can be very easy to fill out or can be very hard depending on the way you handle your payment process. I mentioned there's 4 types. The first one is SAQA. Merchants who have outsourced all processing, transmission, and storage of card data. This is very popular if you're using PayPal or Google Checkout, one of those. Basically, someone comes to your website, they leave to make a payment and come back. You didn't touch any payment information, you're an SAQA. This is the one that you want to be. This is your goal right here. SAQB, this is more for people who have in-person. So those little swipe machines, if you go to the down at the, get some Chinese food or go to the Rite Aid or whatever the place is down over here, CVS. That's all B. And then you get C, basically anyone that has a payment application connected to the internet. Nowadays, that's a lot of people as well because they're all hooked up to payment processors. Now, D is all other merchants. So what's most likely going to happen is with web applications, you're either an A or in a D. And the important thing to point out here is the reason why you want to be an A. If you look, SAQA, time to become PCI compliant is roughly 5 days. If you're a D, it's anywhere from 6 to 18 months. That's a lot of time that you really don't want to be spending dealing with PCI compliance. So you want to be doing the fun stuff. The number of controls that you have to meet, for A, it's 20, over 200 for D. Cost is almost nothing when you're SAQA, from $44,000 to $125,000 when you're D. Hardware and software upgrades, because you have to have all this other crap related to it, is $81,000 to over $500,000. So it's highly recommended that you do A. Don't do D. All right, so there's 4 levels of PCI. Now, we just figured out what we are. We're either going to be an A or a D, and now you know what level. And levels are all determined on the number of transactions you have a year. It's not just transactions, it's Visa transactions. So if you look at the first one, it says level 1, 6 million plus Visa transactions a year. You could have 10 million transactions a year, but if you only have 5 million Visa transactions, you would be a level 2. Basically, anything less than 20K a year, you're a level 4. This is the way the cost breaks out. It's a little more detailed than the previous chart, but it shows you level 1. If you're a level 1 with a 6 million plus, you're required to have this much, basically that much for a charge, and you have to have an on-site audit. All the other levels, it's an SAQ. So if you look, if you're accepting 5 million Visa transactions, your scope is going to be kind of high, and your SAQ is going to be anywhere from an A to a D. If you're an A, your cost is going to be a lot less. So you could, even though you're accepting millions of dollars worth of transactions, you can still get away with an easy PCI cost. Now, I talked about external audits. So basically, an external audit is when you hire a qualified security assessor to come into your office for weeks at a time. These people are not cheap. You thought lawyers were expensive, these guys are worse. They come in, they charge you for everything, staying at a hotel, all the food, and they annoy you while they're on site. You think you can get work done, they bug you, they ask you for data, they ask you for all this information, and they poke and prod at everything. The low end is roughly 20 to 30K, but realistically, it's around 225,000 a year. The upper end companies, the bigger retailers are probably, there's 10% of the people overpaying over $500,000. I'm sure Amazon.com is probably one of the bigger ones since they have all those different things. They're probably paying way more than $500,000. PCI 2, it came out January 1st, 2012, so everyone at this point needs to be on PCI 2. There's some good things that came out of PCI 2. They basically took some vagueness that was in PCI 1.2, or 1.1, whatever version it was, and they narrowed it down and made it more specific. The one thing that's really important for most people is now Amazon Web Services is now level 1 PCI compliant, which is very nice, because before this, there was a very vagueness around the way virtualization worked. Okay, credit card data. This is an interesting one. You're allowed to store credit card data. I highly recommend that you do not store credit card data. They basically say that you can store it as long as it's encrypted, but as soon as you store any data, you jump right into the SAQD. So don't do it if you can help it. There are solutions that I'll talk about in a little bit that'll explain how you can do the same things that you would do if you stored the data locally and still be in a lower SAQ level. So what would happen if you're hacked? Basically, it could go from anywhere from you banned from being accepting credit cards at all. You could lose your reputation and customers. You could be fined up to $500,000 per incident, and you're going to get sued. There's a lot of companies out there that have been hacked, and they're all still in litigation. They're still cleaning up the mess. And it's another thing that's important to note. Even if you are fully PCI compliant and you're hacked, you could still get hit with all this stuff, but at least your exposure will be limited. So it's basically, it's not saying you won't get hacked if you're PCI compliant. It's going to help you control what's going to happen legally and also data-wise. So PCI is kind of big. I basically boil it down to 3 points. The first one, all merchants, regardless if credit card data is stored, must achieve and maintain compliance at all times. Number 2, merchants cannot store certain credit card data, including CVV, track data, merchant strips, PIN data. And number 3, if you store permitted credit card data, you need to store it in a secure way, followed by PCI security standards. So now that you kind of know what PCI is, I'm going to go in and give you some common mistakes, and then I'll go on to another section that's going to go in a little more Django programmer specific, so it'll get a little better, don't worry, guys. So common mistakes, storing credit card information in the database at all, and even worse, storing it in plain text. Don't do it, it's horrible. Default passwords not changed. Poorly coded websites where you have SQL injection. Django's great, we have a lot of protection for that, but there's other vulnerabilities that if you didn't supply patches, you could have the cross-site scripting. If you don't turn that stuff on by default, it's not good. Lack of monitoring and logging. Not using SSL for the payment page, that's crazy. You should always have SSL if you're going to accept credit cards. If you don't, it's just wrong. Logging payment information into the log specifically when there's an error. So Django has that lovely debug error. If you get an error and you're collecting credit card data on that page, you could expose your credit card data to whoever gets that email. Also, it could be in your logs. So if you're keeping your logs for long periods of time, that credit card data is there. And I'll get into a little how to fix this in a couple slides. The other common one is missing security patches. Another reason people don't know, PCI rules are complex. PCI rules change often, it's kind of boring, and there's not much training available, so people just are lazy. They have systems that work fine today, and they don't want to change them. They don't want to take the time to learn the PCI rules. They cut corners to save time and money. People are cheap. Changing stuff costs money. Adding more processes and services costs money. Doing things right takes more time and in turn costs more money. People are cocky. It won't happen to me. Why would someone hack me? My code is the best code ever written. You ever hear that? There's a lot of people out there, there's a lot of bad programmers out there that have no idea how bad they really are. Mostly because they're like a one-programmer shop, or they're just some guy's nephew who was building a website for him. And they just find some stuff off the internet, throw it together, and they don't know anything. They followed some tutorial, and now they're thinking they're an expert. The big one, though, people are dumb. Some people write really bad code, they don't know it. I don't know if you guys know this. There's a Twitter handle that basically collects people who tweet pictures of their credit cards. So if you go to this, you'll see people's credit cards with images, so you can go and easily, put stuff on their credit card. So if people are that dumb just doing that, it's kind of interesting. There was a payment talk yesterday by Joe Jasinski. I probably pronounced it wrong, I'm sorry. He went into a lot of the payment stuff. I'm not going to go into that. So if you want to see it, I'm assuming that the slides and the presentation video will be available. You can go back and do that. But I'm going to go in and cover some other stuff that's a little more high level. Basically, there are 6+ different types of payment options. Third-party payments, hosted payment page, transparent redirect, client-side encryption, self-serve payment page, recurring payments. And there's another one I'll get into a little bit. All of these are great, but one of the key features that makes a lot of these work is tokenization. If you don't know what tokenization is, it's beautiful. Basically, the way it works is you don't have to store the credit card information yourself. The payment processors will store it for you, and they give you a token in return. This is really great because now you can store this unique identifier on your system that is equal to a credit card, and you can use that to charge people's credit cards, refund, and so forth without having to have the exposure of credit cards data in your system. So I'm going to go through the first one. It's third-party payment. This is PayPal, Google Checkout, and so forth. People come to your site, they pick what you want, they hit a button, they leave your site. The risk for this is pretty much none because you're not touching any credit card data, you're not doing anything, the effort's low, you get an SAQA. The flowchart kind of looks like this. Most people are pretty familiar with this, so I'm not going to go over it too much, just the way I described it. The next is the hosted payment page. This used to be popular, it's not so much anymore. It usually was your payment processor would have a page that they would host on their servers, and you'd use an ugly iframe. You couldn't customize anything. You have to basically put your credit card information in, and when you hit submit, it would go to their servers, and then you would have an ugly thank you page and so forth. So this is the old way of doing it. The newer way, Braintree Payments, I believe, came out with this first. It's called Transparent Redirect. So you have a nice, beautiful form that you always do on your website, but your post, instead of going to your server, will go to your payment processor first. Your payment processor will then strip out the credit card data that they need and store it in their token system and replace it with the token and send it to you as a redirect. So all you see in your form on your server is a token and then the other information on that form that was there, and it's beautiful. This is really great. When this came out, this pretty much changed the way a lot of the credit card processing worked. Its risk is low. It's medium effort. You have to set it up correctly. If you don't, you could be exposed to credit card information. But you're SAQA, so you get the customization of your own form with the nice SAQ level of A, which is very minimal effort for PCI. You get to host your own payment page, which is really nice. The 3 people that do this that I know of, I'm sure there's others, Authorize.net, Braintree Payments, Fee Fighters. The next popular one is called client-side encryption. Basically, you install JavaScript on your payment page, and it will encrypt your data before it gets to your server, and all you're going to see is encrypted data, or in some cases, it will actually contact your payment processor, create a token, and then all you'll see is a token. So once again, this is really great because you don't see any credit card information on your side. Downfalls to this, it requires JavaScript to work. So if you don't have JavaScript, you could default to the other solution that I just mentioned, and then it will still work. 3 people that do this that I know of, Braintree, Stripe, and Fee Fighters. Last, which is the most popular, unfortunately, is self-serve payments. This is where you actually have a credit card field on your form. You put a credit card information in there. You hit the submit button. That credit card data is actually sent to your servers. You might not store it, but just for the fact that it touched your servers, it's a red flag to PCI. It sits in memory, and you're automatically in an SAQD right there. So at all costs, please avoid this. Even if you're not submitting credit card data, just for the fact that it's touching your system is not good. This is the typical flow. It just basically comes in, goes right to you. You send it to the this example is Braintree, and then it goes to the credit card network, comes back, and so forth. So everything's going through your server. It's not good. Another type is recurring payments. This is really popular if you have a subscription-based service, and you, like for instance, GetSentry. They charge you so much every month. They don't want to have you enter your credit card every month. So what's nice about this is you basically store it out there. It sits in a tokenization system, and then all they have to do is charge the token every month. And it makes, there's like 4 or 5 different people that do this. Recurly, Stripe, Braintree, PayPal. A lot of the services are doing this. This is really good. Before these services came out, you were required to store your credit card data in your database. You no longer have to do that anymore. Last one I'm going to talk about, it's called edge tokenization. A lot of these services that I just mentioned only really work when the web side of things. If you have an API and you want to accept credit card information over an API, for example, if you're on a mobile app or you're doing something behind the scenes, at CashStar we had an API where our bigger retailers forced us to have credit card information over it so that they could integrate with iPhone apps, Facebook, all these different things. This really killed PCI at CashStar. But luckily, there's this new thing that Akamai came up with called edge tokenization. If you use their system, and you're going through their proxy servers, what happens is when the transaction, whether it's an API or a web transaction, hits a proxy server, they do the same thing that the other folks do is they rip out the credit card data, they send it over to your payment processor, they replace it with a token, and they send it on its way. So even though you're using an API or a web page, it treats it the same way, and you're only stuck with tokens. So now you've got SAQA. Your risk is low, the effort is high, there's a lot of work, and it's really expensive. So this is kind of like a last-ditch effort if you need to. Now the comparison. So if you look at this chart, you have to balance customization, risk, and your SAQ level and effort. And the one that's kind of right in the middle that's really nice is the transaction redirect, JavaScript encryption, and Recurly. Those are basically medium work, but you all get A's for SAQ, or SAQ level A, and the customization is good. So those are the ones I recommend. If you have to do anything, do not touch the credit card data, do not store the credit card data, do not pass go, do not collect $200. So SAQA versus SAQD. I showed you this before, I'm going to show it to you again. Look at the difference between A and D. Pick A if you can. You're going to save a lot of time and effort and money. All right, so here's some tips and recommendations. First one, I said it many times, I'm going to say it again. Don't let your credit card data touch your system. Do not store the credit card data in your system. Always use tokens when available, and never ever store credit. What, did I really say that? I guess it's really important. Even if it's encrypted, do not store it. Once you start doing encrypted data, you have to worry about, okay, you got an encrypted database, or do you do encrypted fields? Once you have an encrypted database, you need to figure out, oh, now I have to encrypt my backups. If they hack your system and then you're using encrypted fields, well, you need a key in order to get the encrypted field. So that means if they hacked your server, they could easily get the key, and what good is it? And plus, it also slows down transactions, having to decrypt and encrypt it every single time. Once again, there's a lovely picture showing how cheap it is. Avoid database encryption. I just mentioned that. Django tips. These are the tips that you guys are most likely going to need. Django Secure is really nice. Django Access is really nice. Use those if you can. I'll get into those in a little second. Use SSL everywhere, not just connecting to your site, but if you have multiple servers and you're sitting in a cloud somewhere, or you have multiple connections across, like your database is sitting in some other data center, it's not in a local connection, use SSL between there, or have a VPN type connection to secure that. Use secure cookies, XSS protection, basically cross-site description protection. Change your Django admin URL. Everyone knows it's /admin. Make it a little different just so that people aren't just writing scripts to look for /admin. Don't log sensitive data into forms. Turn autocomplete off on payment forms so that if someone comes back to a payment page and there's a credit card number that was previously entered, it isn't going to pop back up. So Django Secure, written by Carl Mayer, basically helps you remember what to do stupid things to improve your Django site security. It checks your settings to make sure that you're setting them all correctly. Provide some nice little system utilities to make the project safer. It's available with docs on Read the Docs. It's pretty nice. Recommend it. Django Access. Basically, this logs the information into your Django admin. So if you use Django admin, right now, there's built into Django, there's no logging into telling you how many times people have logged in. This project also checks to see how many attempts someone's logging in. And if they notice that there's a brute force attempt, it will actually lock them out. So this is very helpful. I think this should be probably built into Django core. These little features, it's just amazing how someone could just sit there, bang your site for days, and if you don't even have logging, you don't even know that they're hitting this URL. Error logs. If you're not careful, sensitive data could leak into your error logs and emails. Luckily, since 1.2.6 and 1.3.1, they have these nice new decorators called sensitive variables and sensitive post variables. You put those around your views and you declare which fields are sensitive, and then in your error emails, and I believe in your logs as well, it will replace them with stars. It looks the same way if you put passwords in your, when you look at your debug output. There's some more information on that link right there, which just look in the Django docs. All right, so most people, one of the great features of Django is there's reusable apps. And the reusable apps are, basically it saves you a lot of time. So what I did is I went through all the most popular reusable apps out there related to payment projects, and I checked to see what's the PCI status of those. So I went through and did Satchmo, Lightning Fast Shop, Mezzanine, which cartridge, Django Shop, Django Oscar, and Django Merchant. First one, Satchmo. Basically, it's been around. It's probably the most known one. It is SAQD if you use something other than Google or PayPal. So it's important to note that if you are using credit card data with Satchmo, you are exposed to SAQD. So you just went huge on your cost of running the Satchmo. So that's really important to note. A lot of people don't know that. There is if you look at that link there, it talks into about PCI compliance with Satchmo. Lightning Fast Shop, they're kind of the new kid on the block. They got a lot of new features. But once again, they use credit card data and it touches your system, which means immediately it's SAQD. Mezzanine and cartridge. So Mezzanine is it's more of like the blog platform, whereas cartridge is the shopping cart module. Basically, out of the box, it is SAQD because you touch credit card data in the payment module. Django Shop, from the folks that brought you Django CMS. Out of the box, it doesn't have any credit card payment support. This is great because it lets you implement it yourself. And when you're doing this, hopefully you can use one of the other providers that will then allow you to have PCI compliance to use SAQA. It's still in early development, possibly. I'm not quite sure. It doesn't have that much out there. So Django Oscar. A lot of integrations, SAP, Google eBookstore, et cetera. A lot of extensions for it, but as far as I could tell, it doesn't have anything besides SAQD, which is credit card data touching your system. This one, Django Merchant. I'm really impressed with Django Merchant. This looks pretty nice. They got gateway support for all kinds of great stuff. They authorize.net, PayPal, eWay, Braintree, Stripe, Fee Fighters. They support for offsite processing as well, which is PayPal, RBS. But the big ones are Braintree and Stripe and Samurai. These are the things that I was talking about earlier, where you can do post redirect as well as the Stripe JavaScript. And I recommend this one if you want to stay with Django and use a reusable app when doing payments, because it looks like out of the box, it will give you everything you need without having the exposure of PCI. So if we go through and we do a last-minute compare, Satchmo, and I get the version number so people can see. It's possible it changes after I do this. So Satchmo, D, Lightning Fast Shop, D, Mezzanine Cartridge, D, Django Shop, A, Oscar, D, and Merchant, A. Another big thing is PCI in the cloud. PCI in the cloud is really hard, especially with the different providers. You can't just say, I'm out there, I'm in the cloud. You have to actually look and find a PCI cloud provider. AWS, yes. Rackspace isn't. There's a couple links in there. It's really hard to see. The slides will be available. You can follow those links. Rackspace goes into detail as to why they're not PCI compliant. Use an offsite payment processor like the ones I mentioned, using like Braintree, Stripe, something like that. SSL for everything, load balancer to database. If your database is in a different spot, if you're using a hosted database somewhere else, hopefully they have SSL transport between the two of them. You can do that. Set up monthly security scans. And also, depending on your setup, you might need intrusion detection systems. I've got some links here that basically go into better. PCI in the cloud is a talk in all itself. I didn't have enough time to go into it, so I put a couple things in here so you guys can kind of look at it. The links that we have here, the first one is really long, so I put a bit.ly link for it. Basically, one of the guys from RightScale wrote a really nice PCI compliance in the cloud document, and it's pretty nice. So if you can go to that, it'll give you a lot of hints if you need to get PCI compliant in the cloud. Cloud Passage is basically like a third-party hosted cloud security. They do a lot of great things. I personally haven't used any of these, so I can't endorse them, but I'm just giving you some resources to go look out. Alert Logic, they basically have this new feature called AWS Cloud Security. It supposedly allows you to be PCI compliant using AWS with basically outsourcing a lot of the PCI stuff. You might be wondering, what is an intrusion detection system? There's different types. There's a hardware and software versions. They're network and host-based. And there's a couple examples for software and hardware. But basically the way it works is you set this little thing up, whether it's software or hardware, all your network traffic goes through it, and it does all these little analytics and heuristics to look at the traffic that's coming through to see if any of it is bad. And if it's bad, it basically sends you a notification letting you know that there's some bad traffic coming through here that's possibly trying to hack your system or scan your system and so forth. And the ones that are manned, they actually have human interaction where they can actually go into firewalls and so forth and start blocking these traffic. The ones that are software-based and open source, that's just like an email to you. You have to handle all that yourself. There's different security scanners that are on the market. And the security scanners can be anywhere from an application to a server to a network. Depending on what you need to do, the application scan is basically just going to go out. It's going to scan the application for common things that like SQL injection, cross-site scripting, and so forth. Server is going to look for security vulnerabilities, any other holes or any updates that you haven't applied. And network vulnerability is basically it's going to check to see if anyone is pinging and scanning your network for open ports. So the vulnerability scanners, they also look for remote file inclusion, known application server and network vulnerabilities, and there's a lot more that it covers. You can basically just do an easy Google search and you'll find a bunch of different providers that offer PCI vulnerability scanning. Other things to consider, if you accept payments other than online, you could also accept payments via on the phone if you're a call center, maybe payments via fax or email. All that stuff is still under PCI. So if you have a perfect computer web app, but you accept credit cards over the phone or via fax, it's going to hurt you. So make sure you try to do everything over the phone. I have an original blog post I wrote about this. It's out there. I'm going to update it once I'm all done with the slides and the video of this, and I'll also include all the information that I had so you can follow up. It's kind of like a live document, so you can kind of see how things progress over time. And that's all. Do you have any questions?
recommend using SSL encryption between your load balancers and your databases and your web servers, all of that, regardless of whether you're PCI A or D?
Yeah, so the big thing is if you have your own setup where you have your own servers and you have a private connection between everything, you're probably okay. But if you're like in the cloud and you have like a software load balancer living over here, and then you're trying to connect to a database over here, and you have to go over the public internet, I would recommend SSL or VPN, some type of secure connection between them. But like I said, if you're in your own data center, your own connected with a private network, you're probably fine.
And is that because of PCI compliance, or just you think it's best practices in
It's
general?
best practices. There are some things that are covered by PCI, but I think it's just best practices, because you could set up a sniffer that just listens to the traffic. So.
Okay, thanks.
Hey, so you mentioned Rackspace not being PCI compliant. My understanding is that if you're in the PCIA boat, it doesn't matter because nothing's touching your server. Is that the case, or?
Yeah. So what they're saying is their hardware isn't PCI level 1 certified. So if you use the physical hardware, you're PCI, you're fine. But their cloud provider isn't. And that's because it's in a multi-tenant environment, and they haven't done what's required by the PCI folks to go through that. The documents that I linked to give a little more explanation. But you're right. If you use SAQA and the credit card data never touches your system, you don't have to worry as much. So that's why I recommend if you want to do it, you can do send the credit card data via post redirect or Stripe, and then you don't have to worry as much.
Right. Okay.
Because you don't fall into that category.
Great. Thanks.
For quasi-recurring payments, so like random amounts at different points in the year, what do you recommend, since most of the recurring ones are based upon a fixed amount on set intervals?
Yeah, so all of the other providers also offer the token system that I was talking about, that all that stuff is based on. They also have recurring systems as well, where you can specify specifically, this guy owes $9 this month, $4 the next month, and so forth. So.
And you can do that at random times in the future, or at the explicit?
Yeah, I think you could. It's an API, so I think you write your own. It's not going to be as easy as Recurly that just sets a common thing every 5th of the month. Yeah. It's something you have to write using their API, but you don't have to touch the credit card data, so it's fully functional after that, whatever you decide to do.
Cool. Thanks.
Do you know how many requirements that PCI and the HIPAA security standards share?
Unfortunately, I'm not too familiar with HIPAA, but from what I heard, there's a lot of overlap because a lot of the same security standards are used by the two. I think the big thing is PCI is looking just at credit card data, whereas HIPAA is more like personal data. So if you just replace what you would think would be personal information with credit card data, and I'm guessing you're going to need to store personal information. I don't think there's a HIPAA version of tokenization out there. So as long as you have it encrypted, I'm sure that's the big chunk that is different. Like, how does it need to be encrypted? What's the different things, and so forth.
And does PCI say anything about just personal information, like name, address, birthday, or is it only credit card numbers? Yeah, so there's a slide I kind of went by pretty fast there. But basically, you can keep the name, you can keep the address, but anything beside, and it depends on who you talk to. Some people don't want you to keep too much information. But if you're shipping something, you need the name and the address anyway, so you have to store that. But they're basically saying store as little as possible, because if you get hacked, the name, email, and addresses are as valuable as all this other data. Well, not as valuable, but it is valuable to someone. So.
You were talking about application vulnerability scanners. Are there any other alternatives besides the overly complex OWASP?
So there's different levels of scanning, and I've gone through a whole bunch of different ones. Some are very application specific, where they try to do all these known vulnerabilities. Other ones are just generic, and they go out and they just scan your server for ports, and then once they find a port, they just try to do random things. But they seem to be all doing the same thing nowadays. So you find one, they do the different levels for you, and then you can get even more advanced if you really want.
That's all we have time for. Thank you very much.